Routing with TCP/IP. So is routing complicated? Not really. Is this diagram? Yeah, pretty much. What routing is the ability of a network component called a router to make a decision. So I take a packet in, which port should I send the packet out? Really as simple as that. So let's take a look here. We've got 1, 2, 3 routers on the board here. And we've got 2 hosts right now. Each one of these routers has 1, 2, 3, 4, 5 different interfaces in it. Each interface on the router will have its own IP address. Now I haven't addressed all of them, just the ones that we're going to use for our example. But every interface on the router will have an IP address. Now, where there's 2 routers on one network segment, then the interface on one router will be .1. The interface on the other is .2. Now that's just the standard that I've chosen. All you have to do is make sure that these 2 IP addresses are using the same network segment, same network ID. So they're both on the 4.0 network. Our subnet mask in this scenario is 255.255.255.0. So every time you vary the 3rd octet, you're on a different network segment. Okay, so what we're going to do is run through how this client will communicate with this client, which will be the easy scenario, and then how this client will communicate with another client out here. And that will be the difficult scenario. Alright, so routing, the ability of this router to just decide which port should I send that packet out. Now let's say that client A wants to communicate with client B. Well, he sends a ping to 192.168.1.53. Okay, he tries to establish this communication session. The first thing he does, looks at his own subnet mask and determines that based on my subnet mask, he's on a different network. He's on a different subnet. So my packet goes straight to the default gateway. Default gateway is the port on the router. The default route out for my machine. Okay, so my packet gets to the router. The router will look at his route table and say, can I get traffic to the .1 network? Because what you've said is that I want to send traffic to the 192.168.1 network, and then once it gets there, we'll send it to host number 53. Well, the router, all he cares about is getting your packet to the right network. So he says, can I get it to .1? Well, yeah, I can get it to .1. .1 is right here. So if I have a configured interface on this router, and that's the route that we want to get to, reads its route table, get to it every time. No problem. So the packet is sent to this network, the ARP is sent out, the MAC address is resolved, the communication happens. Okay, now let's say that host A wants to communicate with host C. So A wants to get to C. So we need to have a way to route traffic from the 192.168.2.0 network, this network, to the 192.168.9.0 network, to this network. So I attempt that communication, I look at my subnet mask, I determine that host C is not on my same network, so I send my traffic to the default gateway. The default gateway, the router, will get that traffic, look at his route table, and say, none of my interfaces are the .9 interface. None of them are on the .9 network, so I don't know where to send that traffic. So now the traffic cannot be sent to that other router. Now I could create what's called a default route in this router and say that whenever I don't know where the traffic should go ahead and send it out this port. But I probably don't want to do that in this situation because look, I've got 1, 2, 3, 4, 5 interfaces. And so what if there's a router here and then another router and then some hosts down here? Well, if my traffic is always going out that path, then this traffic will never reach its destination. Okay, so the default route solution probably wouldn't work here. What we need to do is update our route table. Now we can update it in 2 ways. Either use static routing, and every time we add a new router or a new network segment or new information, we have to actually manually add a route. And when we manually add a route, we say whenever you want to get to this network, use this interface. no problem. Or we could use dynamic routing, and with dynamic routing what we would do is load some kind of routing protocol, either RIP, Routing Information Protocol, maybe OSPF, Open Shortest Path First Protocol. With Windows NT, if you're using your NT server as a router, it supports the RIP protocol, Routing Information Protocol. Now, the way RIP works is you're going to broadcast everything that you know out all your interfaces every 30 seconds. So it's okay for a small network, but once you get a bigger network, you probably don't want to use the RIP protocol anymore. So let's say that we are using the RIP protocol on this particular network. Well, my route table would be broadcast out every 30 seconds. His route table broadcasts out every 30 seconds. And so now eventually these routes will propagate around where now I'll know that if I want to get traffic to the 9 network, I need to use this port because it's going to get me to this router, which can get me to this router, which can get me to the .9 network. So routers are really not that intelligent. All they're doing is just taking a packet in and saying, do I know where it should go? Well, yeah, okay, send it there. If I don't, send it to my default gateway if I have one. So they're really not that smart. They are reading the software address of the packet, so they do have to have enough intelligence to be able to read a software address. But other than that, they're just making a simple decision. Send it out one of my interfaces. Okay, let's run through a little static routing exercise / scenario. Okay, in our situation, we've got several different subnets drawn out on the board here. A subnet is identified by the network ID .0. So we've got the 192.168.2.0 network or subnet, the .4.0 network, .6.0, .8.0, .9.0. So if we're this host, we're dealing with the route table on this router here, trying to have this host communicate with everybody. What static routes does this guy need to add? Well, he doesn't need to add a static route for any of his own configured interfaces. He can already get to those. But what if he wanted to get to this interface, or this interface, or this interface, or this interface? Well, to get to these different networks, you would have to configure a static route of this address. Because if I'm going to get to this network segment, or this network segment, I need to be able to get my traffic to that router. Once that traffic is to that router, he reads his own route table, and he says, yeah, that's my own configured interface. No problem. Now, what if I wanted to get traffic to the .9 network? Well, I either have a default route, or we talked earlier about how we probably don't want to have a default route, or I add another static route to get me to the .9 network. Now, when I add that static route, am I going to add a route and say, use this IP address? Well, no, because I can't get to that IP address. I can get to this IP address, and so what I'm going to do is add this IP address as the static route to .9, and then make sure that this router can get to .9. So if we're doing all static routing, I need to also add a static route here for this IP address so that he can read his route table and configure and send me to one of his configured interfaces. So in review, what we've done then is for this router to get to any of these subnets, we add a static route here of that port, 192.168.4.2. For this router to get to any of these subnets, any of these segments, we add a static route again to right there. Now, once we've done that, it's still not going to get there unless we add a static route to this router that will let it get to these subnets, these network segments. And so the static route that will let it get to these segments is going to be this. So get me to this router so that he can read his own route table, send me to one of his configured interfaces. It's much easier to implement routing with dynamic routing using the routing protocols, Routing Information Protocol, OSPF. Let's take a look at the on-screen demonstration now, and we'll see how to configure your NT server as a router.